All right, let's get this one on the road. Good morning, everybody. My name is Russell Keith-Magee. Welcome to Building a Cross-Platform GUI App with BeeWare. Assisting me today is Malcolm Smith over here, and up the back, Russell Martin, who's waving at the back. Before I start, I'd like to acknowledge I am from Wajjuk Noongar Boodja, otherwise known as Perth, Western Australia. I would like to recognise that we are currently meeting on the lands of the Shawnee people, recognise their continuing connection to their lands, waters and culture, and pay my respects to their elders past, present and emerging. So, what are we going to do today? Today I'm going to give you an introduction to BeeWare as a project, the pieces of the project that all fit together to make BeeWare as an umbrella overall. And then we're going to get our hands dirty. We're going to build a GUI app. We're going to take that app in Python, or written entirely in Python, run that app as a desktop app. We're going to package that app for distribution so that you could give it to somebody else and they could install it and run it on their machine. We're going to then take that same source code and run it as a mobile app. We're going to take that code and run it as a web app. We're going to take that code and run it as a terminal console app. Okay? We're then going to look at adding third-party packages and using the rest of the wonderful resources that are PyPI and adding that to your project. We're going to look at some of the details about how you make a good GUI app, how you avoid beach balls and other sort of lockups and sort of the missteps you commonly get when you're building a GUI app. We're going to have a look at customizing your app, how to make it actually appear to be an app that you wrote, not just some sort of generic thing that's popped out of a GUI builder. We're going to take a brief look at permissions and device hardware. So how do you actually make the use of the fact that you're running something on a phone and use all the useful devices and sensors that are on there. We're going to have a quick look at testing applications. And last of all, the slides. If you do want to pick these slides up later, there's a version of them available at that URL down the very bottom. The general format of this tutorial is going to be me explaining for a little bit and then you doing what I've just explained. As we progress through the course of the morning, there'll be less explaining and more doing because the tasks will be a little bit more complicated. So at the beginning, there's a little bit more talking. This is very informal though. If you've got questions along the way, yell out. I'm happy to digress, go down a rabbit hole, whatever sort of points of interest or whatever's interesting to you. We do have a lot of content to get through though. We'll need to keep a good little pace to get through it all. I will go through all the slides today. Depending upon how well the network performs and how fast we actually manage to get through things, we might not actually get through all of the demos and building all of that code. That said, all of the code that you will need to have is either on these slides or on URLs that are linked from those slides, so you should be able to pick up and do that work in on your hotel room or when you get back home afterwards. So first off, a little bit about me. My name is Russell. I am a principal engineer in the open source group at Anaconda. Malcolm is also an Anaconda employee. He works with me on the open source group, in the open source group. Anaconda pays for Malcolm and myself to attend conferences like this one, to talk to people like you. So I'd like to thank them for that support. Russell Martin, down the back, is a volunteer in the BeeWare community. He's not paid by Anaconda. He is here on his own steam. I would like to take this opportunity to thank him for being here today and for the many various pieces of wrangling that he does in the BeeWare ecosystem. In addition to sending Malcolm and I to conferences, Anaconda supports the Python open source ecosystem more broadly by providing direct financial support to organizations like NumFocus and by employing developers like Malcolm and myself to work full-time on open source projects like Jupyter and Number and the open source project that I founded, BeeWare. BeeWare is a collection of open source tools and libraries for creating native user interfaces in Python for desktop, but also for iOS, for Android, for single-page web apps, and for console apps. Anaconda supports BeeWare to ensure that Python remains a viable programming language on the platforms that people are increasingly using as part of their day-to-day computing life, phones, tablets, and so on. However, it is important to know that BeeWare is not an Anaconda product or anything like that. It is a fully open source project with independent governance and funding. Malcolm and I just happen to be paid to work on Anaconda paid by Anaconda to work on BeeWare full time. BeeWare is also not a single product or library or tool. It is a suite of tools, each of which solves one specific part of the overall problem of writing a GUI app in Python and distributing that app to other people on various platforms. Today, we're really going to be looking in depth at two pieces of that suite. The first of them is a tool called Briefcase. Briefcase is a tool for packaging Python applications. You take your Python code and you wrap it up with Briefcase as a standalone unit that you can give to an end user who has no Python experience at all so that they can install it on their platform of choice without ever knowing that they're running Python code. The second is a tool called, or a library called Toga. Toga is a Python native, operating system native GUI toolkit. It provides the tools that let you build a user interface using nothing but Python that is then native on every platform that it is deployed to. Let's go into a little bit more detail on those two. First off, Briefcase is a PEP 518 compliant build tool. So it's a build tool that uses pyproject.toml as its point of configuration. It will produce an MSI installer or raw.zip bundles for Windows. It will produce a DMG or a raw app bundle on macOS. On Linux, it produces deb, RPM, or PKG system packages, so it will support effectively all of the common Linux distributions. It can also produce Flatpaks or app images on Linux. It produces iOS and Android projects that can be uploaded to the Apple App Store and Google Play Store, respectively. And it produces a zip file you can upload to a static web host as a single-page web app. It is also highly extensible. So if you wanted to add a Snap backend for your Linux distribution, you could. Or if you wanted to support an entirely new platform, like set-top boxes or watches or something, you could. Briefcase has a plugin API that lets you do that. So that's what Briefcase is, but just as important is what it isn't. Briefcase is just one part of the overall BeeWare suite of tools, and while Briefcase does integrate really well with those other tools, it does not require the use of those other tools. Briefcase does work really well with Toga, which is BeeWare's GUI toolkit, but you can wrap your PySide app or your Pygame app with Briefcase. The caveat on that is that Briefcase's capabilities are only as good as the underlying frameworks themselves. Briefcase is a packaging tool. It won't make your Pygame app work on mobile because Pygame hasn't been ported to mobile. If that ever was ported to mobile, it would just package it as if it was any other Python package. Briefcase is also not a good match for command line tools, at least not yet on every platform. It does work for command line apps on Linux. This is an area we are actively working on, and I ask again in a month or two, the answer will be different. We expect the next release of Briefcase will include support for command line apps as well. Lastly, Briefcase isn't really a competitor for things like setup tools or Flit or Hatchling or any of the other PEP 518 build tools. The end goal of those tools is to create a wheel that you upload to PyPI and then you import into another project. Briefcase will not produce a wheel. Setup tools et al. Are for distributing Python modules, some of which, like something like Black, might be executable as tools. Briefcase is for packaging standalone applications, things that appear in your laptop, start menu, Launchpad, however you start your apps. How does Briefcase work? Well, the approach that Briefcase uses is essentially the dumbest thing that could possibly work for the problem of app distribution. A Briefcase application is a full copy of your Python code, a full copy of all of your code's dependencies, a full copy of a Python interpreter, and a stub binary that can be used to start your application, all bundled in a way that makes sense for whatever platform it is you're supporting. Now, I say it includes an independent Python interpreter. It's more accurate to say that it ensures a Python interpreter is available on most platforms. That means shipping one, but on Linux, it will use the system package for Linux if possible. It also doesn't guarantee that python.exe is available. All it guarantees is that it can run Python code from a known fixed entry point that, when it executes, will appear in your task manager as whatever the app name you're running is called. And that's pretty much it. Briefcase is fundamentally a templating tool combined with wrappers around pip to install all your Python dependencies and wrappers around whatever native platform tools are needed to build binaries or DMGs or MSI files or whatever, sign applications for distribution, whatever each individual platform actually requires. Now, Briefcase is not the only app packaging tool for Python, so why would you use Briefcase and not one of the others? Well, first off, it doesn't try to be clever. Some of the alternatives to Briefcase, things like PyOxidizer or PyInstaller in some of their modes of operation, convolve getting a working app with making a standalone executable. And in order to support the aim of making that executable, they play some little tricks with your code, bundle it into a zip archive that's embedded into the data block of your executable. It's unpacked at runtime. And that can work. And when it works, it's great because what you get is a .exe file or whatever that you can give to someone and it just runs. But it doesn't always work because fundamentally Python code really, really wants to be run by passing an interpreter over a directory of files on disk. Now, okay, if you know enough about Python's import system, you know that's not strictly true, but if you've got enough practical experience with Python in the real world, you know it's close enough to being true as makes no difference. If you don't believe me, my question for you is why do zip-safe eggs exist? And if you don't know what that means, don't worry, the only thing you're missing is a bunch of headaches. So, Briefcase runs Python the way that Python was essentially designed to be run, an interpreter running over a directory of source code. The only thing Briefcase does is automate the process of getting that working interpreter to an end user in a way that doesn't require them to know anything about Python and doesn't require them to install Python beforehand from somewhere else and then configure how your thing's going to set up the environment that the Python code's going to run and all that kind of stuff. At the end of the day, from Briefcase's perspective, if the end user of your app is aware that it is a Python app, Briefcase has failed at its job. Briefcase is also cross-platform. It supports iOS and Android, which PyOxidizer and PyInstaller don't. It also uses a single configuration file to produce installers for all of the platforms it supports. So things like Py2app work great for macOS, but won't help you build your Windows app. PyInsist will only work on Windows, won't help you build a macOS app, and so on. That means you don't need to configure a different tool for every platform, and thus have a different configuration on each platform, or for each platform you want to support. That eliminates, potential sources of error and discrepancy between the various platforms. Okay, so that's Briefcase. What about Toga? The other major piece we're going to look at is Toga. Toga is BeeWare's cross-platform GUI toolkit. It lets you use a single codebase to write a GUI application for multiple platforms. It is a Python native toolkit. This is not a C++ shaped peg crammed into a Python shaped hole. The Toga API has been designed with Python in mind first. As a result, it uses Python idiom, Python language conventions, Python language constructs. Things like iterators and generators and context managers and properties are all core parts of Toga's API. Toga code tastes like Python code, not like a wrapper around a C++ API or a wrapper around an Objective-C API or around a Java API or whatever else. It is also operating system native. This is not Electron, where every app is actually 3 websites wearing a trench coat. On Windows, your app will look like a Windows app. On macOS, it will look like a macOS app. On Android, it will look like an Android app. And it's not just a cosmetic theme either. Toga is actually using native system widgets to do what it does. Why does that matter? Well, UI consistency is a highly underrated aspect of usability. If an app behaves like every other app on the operating system, that is a transferable skill that users can use to understand how to use your app. But it also means that we inherit system-level features like accessibility out of the box. Screen readers, for example, just work with a Toga app. They work as well as they will for any other native application because your application is a native application for all intents and purposes. It also means apps have much smaller memory footprints because you're not carrying around an entire web browser to make your app appear. You are just putting the 3 buttons you actually want to have in your app window on the screen. But more than that, Toga actually does everything it can to ensure that when you produce an app, what you get is an app that fits local operating system conventions. For example, if you have an app that has a menu, where is the quit menu item? If you're on Windows, it's like under the File menu and it's called Exit. If you're on macOS, it's called Quit My App and it's under the Application menu. A Toga application has these menu items out of the box in the right place, named the right things, bound to the right key combinations with no additional configuration whatsoever. That's just one example of sort of the broader picture here. The idea is that by default, Toga will do the right thing for whatever platform it's on, and any feature it exposes will adhere to native platform interface guidelines rather than it will to try and conform to some it looks the same on every platform design approach. Now, the side effect of this is that Toga isn't ideal for all use cases. Toga, for example, is not a good toolkit for writing a game. The feature set just isn't compatible. If you want your app to look identical on every platform for whatever reason, Toga is not a good choice for you. There is a semi-common sort of theme that pops up in Toga's support channels that goes something along the lines of, how do I put rounded corners on my buttons? The short answer is, you don't. Toga's buttons look like whatever platform buttons look like. If you are on Windows and you do not like the way that buttons look on Windows, take that up with Microsoft, because that's what they want buttons to look like. Toga just uses the system look and feel. There are some light styling tools, but they're sort of more in the vein of make this button look like it's an emergency escape button and therefore it's red, rather than like hand customizing exactly where the pixels are and what the button looks like. So, if you want your app to look the same on every platform, Toga probably isn't for you. And that's fine. If you don't like Toga, you can still use Briefcase because the two aren't tightly coupled. Toga is very good at producing apps that are consistent with platform user interface guidelines. If that's not what you care about, don't use Toga. That said, I will also gladly engage in an extended rant about whether violating platform UI guidelines in the name of visual consistency is a good idea. If you want that rant, hit me up later, buy me a beer. Okay, so enough theory. Let's get our hands dirty. What we're going to do today is walk through the life cycle of building and packaging a project with BeeWare tools. Initially, at least, it is not going to be a very exciting application, but it will be a GUI application written in Python, packaged as a native desktop app, packaged as a mobile app, packaged as a web page, and packaged as a console app. Towards the end of the tutorial, we'll start adding some more interesting features and exploring what more of Toga and Briefcase can do. Right, so just so I know what we're kind of dealing with here in the room, who is on macOS? Okay, so decent number there. How many are on Windows? Okay, decent number as well. Who's on a Unix? Ubuntu, Fedora? Yep, okay. Anything more exotic than Ubuntu or Fedora? No? All right. That's the desktop side of things. Who is an Android user? Okay. Who's on? Presumably the rest are basically iOS, which I guess is basically the Mac users. In terms of level of experience, who considers themselves a gun Python expert? Yep. All right. How about, Python capable, but you're not changing the world? Okay, complete Python newbie, never done Python before, just getting into this. Okay, so we've all got at least some experience. Cool. Is anyone here using Conda as their environment? Got a couple of Condas? Any of those Conda people also on Linux? No? Excellent. Don't have to worry about that then. Okay. Okay, so as I said earlier, this tutorial is going to be a bit of a follow the pattern of, I show, you do. However, in a class like this, it can be a little bit hard to tell when everyone's ready to move on. So what we're going to do is use a little signaling mechanism. We're going to use little post-it notes, okay? We're going to get to a point where I'm going to say, okay, you guys go do this thing. When you're done, stick a little post-it note at the top of your laptop screen, so when I start seeing all the flags go up, I know it's time to move on, all right? So I'll throw these around. Grab a post-it and pass them back. Oh, pass another stack there. Another stack there. Pass them. Grab one and pass it back. And when you're ready to move on, put up your flag. All right. We've got them moving back there. All right. So while that's progressing its way backwards, let's build an app. So, first off, we're going to set up a virtual environment. This is probably the messiest step because every platform is just a little bit different, just to make my life difficult. If you don't already have a Python interpreter, well, you should have all got the email last week saying things you need to install before you turn up. In particular, the macOS users, I certainly hope that you actually have the most recent version of Xcode, because on Tuesday they pushed out a new version and it decided to update for me yesterday while I was sitting in the language summit. Thanks, Apple. Anyway, if you don't already have a Python interpreter, you're going to need to download one. You need to have at least Python 3.8. Newer versions are fine, but not any of the 3.13 pre-releases. Those of you on Linux, you need the system Python packages, plus a bunch of other packages depending on your platform. The URL there gives you the list of the apt-get or yum install requirements. If you're on Windows, there are no additional requirements. There are some downloads we'll be doing when we start hitting the Android side of things, but unfortunately there's a limit to what we can actually do to sort of tell you how to get those. We're just going to have to hope the network stands up when we get to that point. We said those of you who are, there's no one on Linux who is using Conda, but if you are using Conda, that's fine. We just need to have Conda environments. So where I've said virtual environments, use your Conda environment creation. Once you've got Python 3 installed, open a terminal session. On Windows, that's your command prompt, cmd.exe. Create a new directory for this project in whatever location you like to put your tutorial activity. Change it into that directory, and then create a virtual environment for your project. So that should all be, like, no one was absolute novices, but Python 3 -n VM BeeWare, we're going to create a virtual environment called BeeWare, and then you activate that environment. Okay, so just got to make sure every time you open a new terminal session, you source your bin activate, or on Windows, you're running your activate.bat, and you end up with a prompt that says you are in a BeeWare virtual environment. Okay, so do all that, drop your flags, because we've moved on to that step. Once you're ready, put your flag back up, and I will know that it's time to move on. So, first step, create a virtual environment. Oh, everyone has already done that. Excellent. Okay, that's so. Yes, we got one back there. We're asking. Yep. Any doesn't matter if you use a different virtual environment name. That's not going to affect anything. Just as long as you know what it is, and anywhere that I've referred to activating BeeWare, yeah, the actual name itself is not significant. Any virtual environment name is fine. All right. So flags down. Next step, we're going to install Briefcase into that virtual environment. Briefcase is a package on PyPI, so it is a straight-up pip install Briefcase. The Python -m is just a better way of running pip. Brett Cannon has a really good blog post about why that's the better way of doing it, but any pip install should do the job. And you should see that it comes up and says, yes, you've got Briefcase 0318. To confirm it's installed right, just run Briefcase -- version, and you should get your version number spat out at the bottom. All right, so when you're ready, well, drop your flags if you haven't. Stick your flag back up when you're done. All right. Is the network playing ball? It's it's good? Okay, that's excellent. We'll test it later. Oh, how are we going? What do we got? How are we doing? We got flags up. Everyone ready to move on? Looks like we're ready. Okay. So, next step, we're going to start a new Briefcase project. Briefcase has a wizard to help bootstrap the creation of a new project from scratch. Do that, you run Briefcase new, and then you're presented with a list of questions with some explanatory text. You will be prompted for a formal name. That's the name of the app that you show to humans, and an app name, which is a Pythonized version of the name, sort of like the name you would pip install, although we're not going to be pip installing. You will be asked for a bundle. Okay, that is used for namespacing to separate my hello world from your hello world. This is a common format that's used by app stores in particular. It's usually a reverse ordering of a domain name that you control. That bundle is then combined with your app name to make a full bundle ID for your app. So, for example, if my org name was org.beeware and my app name is hello world, my app ID is org.beeware.helloworld, which then differentiates from com.example.helloworld. You will be asked for a project name. Briefcase or a Briefcase project can include multiple apps, so you can put multiple app definitions in a single code repository or in a single pyproject.toml. If you're only going to have one app, you can just use the formal name. It doesn't really show up anywhere. It's just a configuration thing. You'll be asked for a one-line description of the project. You get asked for an author's name and email. This is only used for help text and copyright labels in your actual app, so it's not submitted anywhere or sent anywhere or signed you up for an email list or anything like that. Lastly, you need to pick a GUI framework. Briefcase provides a template for Toga, which is BeeWare's cross-platform GUI toolkit. There is also a template for PySide, PPB, Pygame, as well as an empty app that you can fill with any framework you want. We are going to use Toga for this tutorial, so pick that one off the list. Briefcase provides default values for all of these, so you can just go through the wizard saying enter, 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 enter if you want, or customize as much as you feel like you want to. When you're specifying I mentioned that when you specify email addresses, it's just for personal use, just for the help text and things like that. It would only become publicly visible if you were to actually submit this to an app store, and then that would be your contact email that was on in the app, for example. For the purposes of this tutorial, we're going to be calling it's going to be called Hello World. If you want to pick a different name, go to town. You're going to need to adapt any code we do later on to match to the Hello World, whatever name you end up picking. So, your turn. We're going to walk through the wizard. Be creative if you want to. Answer the questions, and once it's done, you're going to start with let's build a new briefcase app. At the end, it'll pop out and say, select your application, Hello World has been generated, cd Hello World briefcase dev. Don't do this step yet. Just when you've got that prompt, we're ready. Stick your flag up, and we can move on from there. Yep. All right. Well, let's move on. See how we're going. What you should have at this point is a complete stub project, including enough code to start an application and enough project metadata to package that application. If you use an IDE like Visual Studio or PyCharm, you can open up that Hello World folder that has been generated, open it up in your editor IDE of choice, because that's basically what we're going to be working on for the rest of today. We have generated a Toga project, but you will end up with exactly the same files regardless of what GUI framework you pick. The only difference is the content of the files that have been generated. Okay, so let's have a closer look at what's been generated. pyproject.toml is the configuration file for the project. The contents of this file should look a little bit familiar because they'll match the answers you just gave when you ran through the wizard. All of the briefcase options are defined in a tool.briefcase section of pyproject.toml. The top-level project and author identification stuff is all literally in tool.briefcase. So we've got here our project name, our bundle ID, our version, a URL, and so on. Individual apps are then defined in their own sections. So this configuration file defines a Hello World app. So there is a tool.briefcase.app.hello world. Hello World there is the app name, the formal name, Hello Space World. The configuration for the Hello World app is comprised out of the project level settings overridden by the app settings. So the Hello World app will inherit the project level version number, for example. If you wanted to have a different author name for this app in the project, you could add an author name to this block, the app.helloworld block, and that would be applied whenever you built this app. So it's always override with 4 exceptions. There is a sources, a requires, a test sources, and a test requires. Sources defines the list of directories of source code that you want to include in your app. So here, in this definition, we're saying source hello world. That is, basically we're saying source hello world contains the source code for our app. That entire folder will be copied recursively into your packaged application. Any code or resources in that folder will be copied in. So if you've got data files, you can stick them in there. If you've got more source code, you can stick them in there. It can be as deep a project tree as you need it to be. It just gets copied in. The only requirement is that one of your source directories needs to match the name of your app. So in this case, source hello world. If you want to have additional directories of source code, go ahead, no problem at all. One of them has to be named hello world. Requires defines the Python requirements for your app. Again, as a list, using the same format that you'd use as an argument to pip install. So literally just the name of a package, or package double equals version number, package greater than equal to version number, whatever you need to define. You can also do local directory references, Git repository references, anything that would be legal as a thing you can install with pip. Test sources and test requires are the same, but they define the code that's included in when you want to run this as a test suite. Sources, requires, test sources, and test requires are cumulative settings. So if you specify a sources definition at the project level, any application level sources will be appended to the list that's defined at the project level. That's not so much of an issue with the project and app settings, but it is when you get down to the specific parts, because you can also have sections in your configuration file for each platform you're going to target. So for example, here we have the tool.briefcase.app.helloworld.macOS. This is the configuration for deploying this application on macOS, and it defines a requires setting that has Toga Coco and standard NSLog. So the requirements for this app when deployed on macOS will be Toga Coco, standard NSLog, and anything that's defined at the app level and anything that's defined at the project level. Okay, so it's just all concatenated onto the end of each other. As it happens, there aren't any shared requirements at the moment because the app level requires definition was empty, but you could put, like if you want NumPy available on all platforms, stick NumPy in that definition and off we go. Now, for macOS, we only need a macOS configuration, but the Linux configuration needs to go a little bit deeper. This is because Briefcase supports multiple packaging formats on Linux. There is a Linux section for things that are common to all Linux platforms, but there are also then format-specific sections. So, by default, Briefcase will generate a system package for your Linux distribution. So there's a deb configuration, an RPM configuration, and a PKG configuration. So there's a system.debian, a system.rel, a system.suse, a system.arch for each of the platforms that you could potentially be targeting. You could also add a system.ubuntu if you have different packaging requirements for Ubuntu versus Debian, for example. That lets you specify system-specific requirements. Usually, like you'll notice in that file that's been generated, there's a bunch of system packages that are being defined. For those of you who are on Linux, you should notice the system requires value will match very closely to the URL that I sent in the email last week, the list of packages that need to be installed. It's essentially, these are the packages that need to be installed in order to build my app, and these are the list of packages that need to be there in order to run my app at runtime. Briefcase also supports AppImage and Flatpak output formats. These are sort of Linux attempts to provide the single binary in an app store kind of experience, but for Linux users. When they work, they're great. Your mileage may vary. AppImage in particular used to be Briefcase's default. We are in the process of probably deprecating it because it really doesn't work that well. Basically, at this point, you can't package a Toga app because of issues in the way that AppImage works. So the capability is there. You can use it. Probably my advice would be to steer clear. Flatpak has a lot more legs in terms of format. There are also sections for Windows, for Android, for iOS, for web. Scan through those at your leisure. They all follow the same patterns. This stub pyproject.toml file has been generated for you by Briefcase New, but you don't have to use that wizard. If you've got an existing project, you can roll your own Briefcase configuration from scratch. You just write up a pyproject.toml that contains all the keys that you need it to have. Or there is actually an alternate wizard, Briefcase Convert, that will try to pull values from a project with an existing pyproject.toml and turn it into a Briefcase app if that's something that you've got. One more detail. Those of you who are familiar with PEP 621, the app metadata standard, might notice there's a lot of overlap between what tool.briefcase configures and what PEP 621 defines. Things like your license, your description, your author details, and so on. The thing is, Briefcase predates PEP 621, so we didn't have a standard to adhere to at the point at which we set up our configuration files. This is a known issue. Over time, the aim is for Briefcase to converge on PEP 621 and deprecate our own settings wherever possible. Right now, in the meantime, a lot of these keys will be honored if they are defined in PEP 621 format. So if you have a project level version, that will get picked up by Briefcase, but will be overridden by the tool.briefcase section, which will be overwritten by the app section, which will be overwritten by a platform-specific section, and so on. We have the support there for version, your name, the name and email of the first author defined in the project section, dependencies maps to requires, there's description, there's a license text, optional dependencies map to test requires, or the test section of optional dependencies maps to test requires, and the homepage URL definition goes to URL. So, Briefcase has generated an application, and the last thing it did was give you instructions on how to run it, so let's do that. Briefcase has a developer mode, which lets you rapidly iterate your configuration and application code. If you run Briefcase dev, Briefcase will use your pyproject.toml definition to work out how to run your project and then run it in your local virtual environment. The first time you do this, it will install all of your declared dependencies and then it will start your application. Now, keep in mind the design motivation for Briefcase. This is the dumbest thing that can possibly work. Briefcase dev is really not much more than a shorthand for a pip install for a list of requirements and a Python -m hello world to start your application. There is a very tiny little bit of extra that it's doing to sort of set up the environment and turn on some debug parameters to make it sort of map a little bit more like what happens at runtime in your app. But it actually doesn't do anything you couldn't do manually, okay? And in fact, if you turn on verbosity, you say briefcase dev -vv, it will tell you exactly what it is doing. It will actually print all of the environment settings, all of the environment variables, all the command lines that it's actually running one at a time, so you could go through and manually reproduce the environment if you wanted to, which is something we actually end up doing a lot of the time for debugging purposes. Why is this app not starting? Run it in verbose mode. Okay, we're getting an environment variable wrong, or whatever else. And so if you do that, what you'll get is a working app. It will be an empty window, but it will be a working native application running on your platform of choice. There will be an app icon in your taskbar. The app will have a menu with some basic menu options in it. You could now go ahead and iterate on the code in your app, add some features, fix some bugs, whatever you need to do. So, your turn. Make sure you're at a shell prompt in an active virtual environment, whatever your virtual environment is called. CD into the hello world directory that was generated and run briefcase dev. What you should see is an application startup icon appears in your taskbar. The only thing I will note on macOS, the app won't be won't advertise itself as Hello World. It will advertise itself as Python, because at least at the moment we're in development mode. This is just get the code running as fast as possible so we can have a fast development cycle. But otherwise, the app will be running as it would actually appear. So close the application, choose quit from the file menu or just close the window, then run it again with -vv. The second time, you should see that it doesn't do any of the installation steps. It only installs the app's dependencies the first time it is installed. We'll come to how you can sort of work around that later. But it will just start the app. By adding the -vv, you'll see the actual command that it runs to start the app. Okay, so your turn now. Flags down if they're already up. Flags back up when you're done. You should have started the app twice over. Yep. What do we got? We got flags up? Okay, let's move. So, if we open up source hello world app.py, you'll see the code for the app that you've just generated. Okay, it is defining a Toga application. So on startup, the app creates an empty box as content. It creates a main window. It sets the box to be the window's content, and then it shows the window. That's it. Okay? If you had picked a different GUI framework in the wizard, the content would be different. It would be a bare bones PySide app or a bare bones PPB app, or no application at all. The only hard requirement is that Briefcase is that your app, or if you have an app called foobar, there must be a module named foobar in your project, and that module must be runnable. So it needs to have a dundomain.py. So effectively, you need to be able to say Python -m hello world to run your app. So now we need to be able to show off some Briefcase packaging. So I need to give you some actual Toga code to work with. If you visit that URL, you will see an updated version of the hello world class. Copy that class definition and replace the one that is in the app.py, the source hello world app.py. Make sure you keep the imports at the top of the file and the def main at the bottom. We are only replacing the hello world class itself. Okay? If you got creative and use an app name other than hello world, you might need to preserve the old class definition. The contents of the class will be fine. We're just looking to preserve the class definition as it was before. So hit up BeeWare tutorial 1, copy that code into your app, and then we'll have once you've got that code in your app.py, let me know, and we'll have a walk through what we've just added into your app. All right, so I might just move on. Got a bunch of flags up. So what is in our app now? Well, just as before, we're creating a main box for content, but this time we're adding some style. Toga lays out its applications in a way that is very similar to how you would lay out HTML or HTML on a page. It's a tree of content, a parent container that has containers that have the widgets that you actually want to display. And each of those nodes of that tree, you can then associate style with it. Toga uses a style framework called Pack. Pack is very closely inspired by CSS3 Flexbox. In fact, it can actually be mapped one-to-one to CSS in its actual implementation, which we use when we get to the web side of things. If you've done any web development, a lot of the directives you're going to see here are going to be very, very familiar. Okay, so in this case, what we're saying is that our main box, is a column box. We want all of the content to be stacked on top of each other and go sort of vertically as you add new widgets, they get below, or they're stacked below the previous widget. We add a label. It's going to have the text, your name, and it's going to have some padding around the outside because we've got some styling there to say we've got some padding around the outside. And we're going to define a text input called name input. It's going to be flexible, okay? It's a text input and its style is flexible. The flexible means that when there is an option to make this widget get bigger or smaller to adapt to the size of the window, it will absorb space. So this text label will get bigger if the option presents itself. We then create an additional box called name box, and this one is going to be a row box with some padding around it. So the row box means that all of the widgets are stuffed left to right as you start adding content into them. And then we add the name label and the name input into that box. So we're essentially going to have a box that contains a label and then a name input next to it. We then define a button with some padding, and we say that when that button is pressed, we want to invoke a function called say hello. Okay, so the button itself will say hello with an exclamation point, and then when you press that button, it's going to invoke a function on the app called say hello. And then finally, we add the name box and the button into the main box. Now, because the main box is a column box, the button will be underneath the name box. The name box is a row box, so there's a label on the left and an input on the right. Then, as before, we define ourselves a main window. We set the content of that main window, and we show the window. Okay. Last of all, we define our say hello handler. Okay. This is the function that's going to be invoked whenever the button is pushed. For now, we'll just read the value of the input and print it to the console. Nothing fancy, but it's something we can demonstrate the button's actually doing something. All right, so having got all that code in there, make sure you save app.py and run briefcase dev, and you should see a new version of your app. Okay, it won't install dependencies because the app has previously been run in developer mode. It will just start up, and you should see the layout that we've just defined. There is a button underneath a row that contains a label and some text. Type your name into that box, press the button, and in your console window, you should see it will say hello, whatever text that you've entered. Change the name, press the button again, another line of content, and so on. All right? So, your turn, briefcase dev. See what pops up. And yeah, it looks like everyone's pretty much done that straight away. So, congratulations, you now have a native application that does nothing interesting whatsoever. However, we are still running this application in development mode. That's great for development, but we want to give this app to somebody else. So how do we do that? Well, now is where we really start using Briefcase. The first step, we need to create our application. To do that, we run briefcase create. This will do a bunch of things. First, it will look at the platform you're currently on and get an application template for that platform. So I am currently running on macOS, so it will go and get the briefcase macOS app template. If you're on Linux, it'll get a Linux template. If you're on Windows, it'll get a Windows template. Second, it will obtain a support package if it needs one. A support package is essentially a version of Python that can be embedded into your app. For Windows, we actually use the officially distributed Windows embedded package. For macOS, the BeeWare project maintains a support package, which is basically a build of Python. We're probably about to move to actually using a sort of simplified version of the official Python installer for macOS. One of the projects that Malcolm and I have on the roadmap, probably for Python 3.14, is to get an official installer that can be used for embedded mode for macOS. Hopefully also Android and iOS. on Linux, we use the system package. You have installed Python. Python is available as a system resource. It will use that Python. But whatever your platform, Briefcase will download that support package if it needs it, unpack it into the application template we've just created. Briefcase then installs your application code. It's basically a copy of everything you listed in your sources. It then downloads and installs your app's dependencies. Now, you might say, but hang on, haven't we already installed our dependencies? And you have, but you have installed them into your local virtual environment. Remember, we created a virtual environment to build this application. That is where we've installed those dependencies. Your end users don't have access to that virtual environment. We have to create a new virtual environment that is part of the bundled application. Briefcase is creating a standalone distribution environment. The two are very separate. Just because you've added something to your local environment doesn't mean it's in your app's environment. Then, Briefcase installs any application resources like icons, nothing at this stage, we'll get back to that, and then it's done. You have a complete application template. Your project directory will now contain a build folder that, if you dig into it, you'll see that there's a whole bunch of code that it's generated, and it varies depending upon what platform you're on as to what content is in there. So, your turn. Briefcase create. There is basically nothing to do other than that, and then watch a whole bunch of text go past. It will take a little while to get up there, but when it finishes, it will say something along the lines of created build hello world macOS app, or words to that effect. It's using this, yeah. So if you've previously downloaded them and you are on the same, targeting the same platform. So in this case, you're on macOS, you're building for a macOS app. It will use the standard pip cache. So yeah, it will already have it. It will already use it. Yep.
In the project directory, where does it put the bundle of requirements? So like, I understand the virtual environment. Can I actually see where, when I run create, where it put them?
You can see where it's put them. It's all in the build folder, and which platform you're on. It will vary depending upon where you are. You'll be looking for a directory called app_packages, but explore and see what you can find. Don't touch too much, otherwise you might break things.
I noticed that Briefcase uses a template from Git.
Yes. So what we're using here. Like I said, Briefcase is basically a fancy templating tool with a bunch of wrappers around some other pieces. When it is developing your application, it is a cookie cutter template. It is literally a GitHub cookie cutter template. It's a Git repository. If you want to customize that template, you can. So you can go take that template, fork it, add whatever modifications you want as your default starting template. Whatever you do. It's up to you to make sure it works, but you can make whatever changes you want to. And then you can modify your Py project to say, use this URL as my template, or use this branch of the template as what gets used when I roll out my app.
Is the template URL already set within the Py project?
It is not set by the Py project, but if it's not defined, it falls back to the default value, which is basically constructed out of what platform, what format am I targeting. Okay? All right, seeing a bunch of flags there. So we've got a created app. Next step, to build that app. And I'm sure you'll be shocked to hear the command to do this is briefcase build. Now, what happens here varies wildly depending on the platform. On macOS, it needs to sign the bundle. Particularly if you've got an M1 Mac, you basically can't run code or run an application unless it has been signed somehow. macOS provides this thing called ad hoc signing, so that you can just kind of make it work on my machine but nobody else's. And so it has to do an ad hoc signing of that app bundle. Your app will be signed. On Windows, it needs to write some application metadata to make the application appear like on the task manager as the app that you've just generated. On Linux, it needs to actually compile a stub application. It ships part of the thing that got rolled out in the template is an actual C program to start your application, and it compiles it using your local GCC and GTK and all the other libraries that are around. So you do that, briefcase run, and ultimately it will spit out something like build hello world macOS app hello world.app. That text will change depending upon what platform you're on, but it'll be something of that ilk. Once that has finished, you can then say briefcase run, and that will run your application. And if you do that, what you should see is a running application. This will look very similar to the one that you ran with Briefcase Dev, but there are a couple of key differences. Most notably, wherever your app shows running applications, it will now register as your app's formal name, not Python 3 with a little grey B icon. It will actually show up as the app that you've actually run and bundled. Okay, so off we go. Briefcase build, and when the build finishes, briefcase run, you should see an app start up and an icon appear in your taskbar. All right, so flags down, back up when you're done. Sorry, question? Yep. Oh, yep. What do we got? Oh, is it the internet is having a moment? Yeah. Yeah, so that is the app. The macOS app template and the Windows app template are large because they contain an actual binary in them. That is something we are in the process of trying to fix because the binary, like every time you change the binary, obviously the repo gets a little bit bigger. So we're working on that one. All right, so I think what I'm hearing is that the macOS people are waiting for a large repo to clone, but everyone else has basically got a working running application. That sound about right? Yep. Okay, so we can keep that one running in the background for those who are waiting for it to download, but it'll basically be briefcase create, which you've done, briefcase build, briefcase run. The next step is briefcase package. Okay, so we're going to run briefcase package -- ad hoc sign. Again, this is a signing thing. We've got to provide some credentials. Briefcase will manage the process of finding the credentials that are available on your system. Setting up signing credentials for an app is a tutorial unto itself. So there are some instructions in the briefcase documentation about how to do that. But for our purposes, just to sort of get something going, and because you don't want to have to give Microsoft $100 for a root sign certificate and all that kind of stuff, we're just going to use ad hoc signing. Briefcase package ad hoc sign will create for your local environment an installable package. So on Windows, it will produce an MSI file. On macOS, it will produce a DMG, installable, a mountable disk image that you can double-click on with an icon that's in it. On Linux, it will produce a RPM, a DEB file, a PKG, depending upon what architect or what Linux distribution you're on. Once you've run that, or once you've run briefcase package ad hoc sign, you will now have a dist folder, and in that dist folder, there will be a hello world.dmg or hello world.msi or something like that. So you can then install that installation artifact. So open up that dist folder in your file manager and double click on it. If on Windows, it will then walk you through the familiar installation process, the installation dialog you see when you run an MSI file. On macOS, you'll get a little mounted DMG file, and you could drag your icon over to the applications folder. On Linux, you'll have a deb or an RPM. You can install that package with dpackage or apt, whatever your local conditions require. So that's the next step. Flags down, stick them back up once you've sort of got an installed version of that app. And when it has been installed, like for example, on Windows, you could go to your start menu and you should see a Hello World option in your start menu. All right? Yep. Got a bunch of flags there. All right. So at that point, those of you who haven't had a couple of little twitches along the way, we have just packaged a Python application for distribution to someone else. That MSI file, that DMG file, or Linux system package, you can give it to somebody else, they could install it on their machine. They do not need to know how to install Python, they do not need to know how to do anything other than install an application the way that you install any other application. Some caveats about packaging. We can't currently sign packages on Linux. Patches welcome if you understand how to do signing on Linux. If you are on Linux and you want to package for another distribution, so create an RPM when you're running on Ubuntu, you can using Docker. Briefcase will manage the entire process of using Docker. You just need to make sure that Docker is available. If it is, you can pass in -- target with an ID for a Docker base image. So briefcase package -- target Ubuntu /noble will produce a 2404 package for Ubuntu, no matter what Linux distribution you're If you are, oh, sorry, you can even run the application inside the Docker container. So you want to validate that your Mac, your 2404 Ubuntu app will run, and you're on Fedora. You can use Docker to run the application and just export the X Windows display out into your desktop machine. If you are on macOS, you can also build packages for Linux using Docker. Briefcase package Linux with a -- target will do the same Docker trick. But if you are on an M1 Mac, you can currently only produce a ARM64 binary, so you won't actually be able to use that binary anywhere really on Linux. Unfortunately, the Docker trick doesn't currently work on Windows. You also can't build a macOS package on Windows or a Windows package on Linux. For that, you really need to turn to a CI platform. GitHub Actions provides macOS runners, Windows runners, Linux runners, so you can build the package in CI, configure all your signing credentials as part of secrets, and just have binaries get spat out as part of your nightly CI process.
So even if you are running WSL on Windows, you can't build on Linux?
WSL looks and smells a lot like Linux, but just isn't quite close enough to actually match, because at some point you've got to ask sys.platform, and sys.platform is Windows, but it's not, and etc. Right, building Linux packages on macOS does highlight one important feature though. So far we have basically been saying briefcase command for everything we're doing. Briefcase create, briefcase run, briefcase package. In every instance, that's actually a shorthand for briefcase command platform format. But briefcase will identify your platform and pick a default format for that platform. Most platforms have alternate formats. So, for example, on macOS, we have been using, by default, the app template, but there is also an Xcode template that will generate a full Xcode project for your application. If you want to go into that Xcode project and add additional codes or add additional code or additional configurations or additional frameworks or something like that, you can use that as a starting point. The app template actually uses the Xcode template to build the stub binary that it uses to build the app. So yeah, briefcase command platform format. Briefcase will fill in the gaps there whenever it can. There's also a Visual Studio template for Windows. There is a Flatpak format for Linux. There is an app image format for Linux, and so on. Okay, so we have packaged our application. We then distribute it to our users and profit, right? So then someone finds a bug or finds a new feature. We need to modify our application. So let's make a little tweak to our application. Edit app.py, replace the implementation of say hello with a new body. So instead of printing to the console, we're going to pop up a GUI dialog, a little GUI dialog as well, or instead, that says hello, name of user, hi there. Make that change, save the file in app.py, and then run briefcase dev. Type your name, you should see a dialog. Hey, great, we've got a GUI dialog giving us the feedback or giving us the information we've stuck into our text dialog. We then run briefcase run and see what happens. Okay, off to you. A couple of people have just picked it up. Right, so you've done briefcase dev, you ran briefcase dev, delightful dialog popped up. You ran briefcase run, dialog did not pop up. What happened? The app has not been updated. Why has it not been updated? The packaged app is a completely standalone copy of your app's code. So when you changed your app's code in developer mode, you then need to update your packaged bundle to include the new packaged code. So you could do that by just blowing away your entire build directory and starting from scratch. That's fine, and actually is not such a bad idea. You should essentially be treating the build directory as entirely ephemeral. Or you can run briefcase update. Okay, so if you run briefcase update, it will go through and copy in your application code again, do all the other sort of build steps that are involved, and then you've run briefcase run, you should then have an updated version of that code. But that's two whole commands, ain't no one got time for that. If you were to go through and make another code change, and then say briefcase run -u, that will do an update and then do a run in one step. Okay, so if you want to go through here and just say briefcase update, briefcase run, see your change, make this additional change, and just say briefcase run -u, it should pop up straight away. Okay, I'm seeing a bunch of flags up. So has that, we've got run a briefcase -u, we've seen an updated version come through on one pass. Yep, looking good. Okay, so As an aside, briefcase will also imply, in most cases, the earlier steps if they're required. So if you have a fresh project straight out of briefcase new and you run briefcase run, briefcase will detect there isn't a template yet and create it, and then it will build it, and then it will run it. Russell Martin is actually currently working on some stuff that will make that even more responsive. So hopefully this run minus u actually will be implied as well. You won't actually need to worry about that one. But that's for a future version of briefcase. So a summary of what we've done so far. We have stubbed out a new application with briefcase new. This all could have be done manually, but we used a wizard. We ran our application in development mode. We've created our application with briefcase create. We've built that application with briefcase build. We've run the application with briefcase run. We've packaged the application with briefcase package. We've then updated the app with briefcase update and then rerun, but we could have also done briefcase run minus u. All of those commands could have been run in long form, inferring the previous steps. The general form of every briefcase command is briefcase command platform format. So briefcase run is really a shorthand for, on macOS, briefcase run macOS app. That matters because some platforms have more than one packaging format, and it's not just create, build, run, package, all follow the same basic pattern. Okay, so we have got a packaged desktop application that has a GUI and pops up a dialog. Let's take that app and run it on our phones, or at least on a phone simulator. Now, we're not going to make any changes to our source code. We currently have an app that pops up a dialog, there's a text input, type name, press button, dialog pops up. We're not going to make any changes to that. We're just going to run it on our phones. Okay? We're going to add iOS or Android to the end of each of the commands that you've run so far. This is exploiting the briefcase command pattern that I've just described. The default is whatever platform you're currently running on, so Windows, macOS, Linux, but you can pass in any other platform that you want to target, iOS and Android being two of the other platforms that you can target. Okay? iOS builds will only work on macOS because all the tooling needed to deploy to iOS is only available on macOS. Android builds, though, will work on Windows, macOS, or Linux. This is, however, where we really start to test the network because Android users are going to need to pull down some big files, and unfortunately, this isn't something we can prep because there is a small file that it downloads, and then that file downloads a bunch of other things. The good news is that I think coffee might actually be just out there. We're about time for coffee, I think. So this might be a point at which we start a process running, take a short break for coffee, and then when it comes back, with any luck, it has downloaded all the things we need to run the application. If you're on macOS, the good news is that the thing that I told you to install last week, you should have all the pieces you need to just run the application. So briefcase create iOS, briefcase build iOS, briefcase run iOS. It will take a minute or two to compile, but it should pop up pretty much straight away. So that's the next step, getting it running on mobile. Run those 3 commands, and hopefully you should have a simulator pop up that has your application running in the simulator. Point out, when you get to the briefcase run stage on Android, or when you're at the briefcase run stage on iOS, it will ask you for what simulator do you want to run this on. So you can basically, on iOS, it will ask, do you want to run this on an iPhone 10 or an iPhone 15? Do you want to run it on an iPhone SE, whatever? The iPhone SE 3rd edition is my usual go-to. It is just a readily available one that's already there. But you can use any of the simulators. It doesn't matter. On Android, it will ask you which simulator you want to run on, and they give you the option of creating a fresh one. My suggestion is create a fresh one. So it will create a BeePhone, which is a Android 31 Pixel 3 or look and feel. So, Pixel 7. Sorry, it's now Pixel 7. Create that. You create the default device. Again, you can just kind of select the default values when it pops up. And you will have a simulator or an emulator for Android running on your phone, or running on your desktop. All right. Looks like we've probably still got some Android builds that are downloading. I'm at 98%. Of the first one, I'm sure. Yeah. All right, so what we might need to do here, particularly for the Android ones, is sort of park that in the corner and let it happily download in the background. We can keep going with the rest of the tutorial. Most of the rest of the tutorial, we actually don't need the Android stuff to be there. Once that finishes, we can sort of demonstrate stuff on Android, but we can demonstrate a lot of the other stuff on desktop or well, other platforms, which we're about to look at anyway. So, oh, hang on, we've still got a couple of people. Yeah, all right. Hang on, let's see if we can find some other people outside. By the way, we've also got stickers down the front here if you want to decorate your laptops or whatever. So. All right. So, like I said, if you are waiting for the, in particular, the Android builds, those of you who have got iOS, or sorry, those of you with Macs, raise hands. Okay, how many of you have not got the app running in the iOS simulator? Okay, so there we go. So those of you who are running on the Android, it might be a good idea to sort of just leave that terminal window where it is. It'll just happily kind of download a bunch of stuff. Keep an eye on it, because once you get to the briefcase run, it will need to do a bunch of downloads as well. So let it do its thing in the background, sucking down the internet, and we'll just sort of keep going, and you can sort of see that pop up eventually. Right, 2 more variants for us to play around with, web and console. Now, again, we're not going to make any changes to our source code. We're just going to change how we invoke briefcase. If we add web to the end of each of the commands we've run so far, briefcase create web, briefcase build web, briefcase run web, what will happen is it will roll out another version of this template and the Toga web backend, install all the code for that, and then it will start a local web server, provide a localhost URL, and then open a URL in a browser on your machine. What's going on there, you'll then see a GUI pop up that will look like, it's a web, it'll be the same GUI we've been building, a text input and a button with a bar across the top that says hello world, but it's in the browser. And when you push the button on the browser, the code is all running in your browser. Okay, what we're using is PyScript, which is an embedded WebAssembly implementation of Python. All the code that is running in the browser. Okay, so that is then a WebAssembly version of your app that is running. That could be, or that is packaged up as basically just a static directory. You could just drop that onto a web server somewhere, and you would have a version of your app running in the cloud, running on a web server somewhere. We're then going to install Toga's textual backend into your local environment with pip install toga-textual, and then slightly modify how we run briefcase dev. That will then, when you say set the Toga textual backend and run briefcase dev, that will run briefcase using the textual backend, which is a console app or console framework. And so you'll see exactly the same user interface, but this time rendered in ASCII text in your terminal. If you're on Windows, you need to set the Toga backend in variable rather than just doing it on one line. So you set a local environment variable, then run briefcase dev. Once you've done that, you want to uninstall Toga textual. This is basically just for demonstration purposes to prove that, yes, we've got 2 other backends here. We've got a web backend, we've got a textual backend. The caveat is that for Toga's purposes, these 2 backends are very much experimental. Okay, they are proof of concept to show that we can do it. There is a lot of work that still needs to be done before those are fully battle-hardened and ready to go. It is more a demonstration of sort of the broader sort of Toga ethos that the way you describe a user interface and the way that user interface actually renders for the end user are 2 completely different things. And we can render this idea of a text label with an input with a button that when you press it pops up a dialog in any platform, as long as it's got an ability to push a button and have an input. Okay, so try those 2. Do a briefcase create web, build web, run web. You should see it pop up in a web browser. Then install Toga textual in your local environment. Set an environment variable, Toga backend equals Toga textual, and then pip run briefcase dev, pip uninstall Toga textual once you're done. All right. So flag.
I noticed that the web is using Python.
So it is using, yes, it's using PyScript, which is an accessibility layer over the top of PyDide. PyDide is Python for WebAssembly, basically. So, how are we doing? We got flags. People seen the web and we've seen a web and a text interface. Yep. Okay, just to make sure, once you've finished that up, uninstall Toga textual. Essentially, what's going on here is that this little Toga backend trick, in your local environment, you will have, come back. There we go. In your local development environment, you will have both Toga Textual and Toga Cocoa or Toga WinForms or whatever your local system is. This setting Toga backend as an environment variable is essentially saying, hey Toga, this is the backend I want you to use. If you don't have that environment variable set, it will say, okay, you've got two backends installed, I don't know which one I want you to use. So you need to uninstall Toga Textual to flush it out and make sure you've only got your WinForms one available. Sorry? All right. So we have now deployed our application to all of the platforms that Briefcase supports. So let's go back to our app and make a few more changes. A common thing that apps need to do is to hit an API to retrieve some useful data. So let's do something simple in that vein and change our app so that the message that we're displayed is being populated by an API call rather than something that's been hard-coded as a text string in the app. You might be familiar with the requests library for hitting HTTP APIs. We're going to use a slightly different library called HTTPX for reasons which we'll get to in a little bit. The HTTPX API is very similar to requests, but HTTPX as a library has a couple of features that will become very useful in the next step of the tutorial. So, in your app.py, in your app's code, right at the very top, import HTTPX, and then modify the say hello handler to call that API. We create a HTTPX client, make a web GET request on JSON placeholder.typicode, parse that response as JSON, and then take the contents from that JSON and stick it into the dialog. The URL that we're hitting here, this JSON placeholder, is basically just a placeholder API. It is something that gives you back JSON content. It's basically lorem ipsum posts to a blog. It could be anything else. We're just using something that's readily available and has some content. All right, so make those changes to your say hello method and then run briefcase dev. Those of you who are ahead of the game might realize that this will have a problem because it will fail with an input error because HTTPX isn't in your local environment. So you can pip install HTTPX and run briefcase dev. The app should then run call off to the API, populate the dialog with the content from the web request. All right, starting to see some flags pop up. We've got a web request populating contents of dialog. Yep. How are we going? We've got flags up. People hitting the API. Yep. All right, so we've added some code to do a HTTP request. We're running briefcase. We've pip installed HTTPX. We're running in briefcase dev and everything's fine. If we now do briefcase run, you're going to see an error. Why are you going to see an error? Again, because we needed to run briefcase run -u. But even that is going to raise an error because we are not telling our application that we have a dependency on HTTPX. Okay? So, in your pyproject.toml, you need to add into the requires block a definition that says you're using HTTPX. We're just using a bare HTTPX here, but it could be specifying a particular version if you wanted to for reproducibility purposes. Then once you've done that, you say briefcase run -u -r. So it's going to both do an update, but also update the requirements. Okay? Installing requirements obviously takes a little bit of time, so we don't do that by default every single run. If you do add a requirement to your project specification, you need to add either briefcase update -r or briefcase run -r to force a reinstallation of all of your project's requirements. Why do we need to do this separately? Again, the application that is packaged and bundled is a separate environment, a separate install of everything, separate to your development environment. So if you've got a requirement in your development environment, a package that's available in your local virtual environment, it's not available in your app unless you declare it as being available and then update in a way that forces that installation. Yep. We do, yeah, so no, we don't have an interface to do that at present, no. Possibly, yeah. I mean, the biggest issue is basically having tools that read and write TOML, preserving white space and all that kind of thing. But yes, sure. Yep. Sorry, say again? Sorry, there's a required statement that's there is the one that's right at the very, very top. Okay, it's the one that is project-wide, because it doesn't matter what platform we're targeting, we want HTTPX to be available. The one that is in the macOS block are the requirements that are only installed for macOS. The one that's in the Windows block, the one that's only requirements only installed on Windows.
Does that mean that like, when you import that, then that's where it's
That there is the name of the package on PyPI.
right?
Okay, that happens to be also the name of the package for most packages, but it doesn't have to be. So it's, whatever. Consult your local documentation for details. Yeah. So this here is the name of the thing you are pip installing, and if you actually put the -vv in there, you'll actually see it's doing a pip install and what it's installing. But you could put in there a Git repository. You could put a directory of local source code, which we actually do for testing purposes, pointed at a development version of Toga. Anything that you could pip install, you could put in that list. It will use however you've configured it. So like it's the the syntax ends up being git plus HTTPS whatever, or git plus SSH colon. Yeah, exactly. Yeah, it's whatever you could put in a requirements.txt file basically. How are we going? We have updated applications using HTTPX, briefcase run -u -r. Yep. Okay. All right. So when you ran that briefcase run -u -r, you should have seen it run and get the dependencies. The app then starts. You press the button. The dialog pops up. Some lorem ipsum text in there in your packaged application. In an ideal world, you probably would have made the requires change first and then used briefcase dev -r to install the requirements into your development environment. But things happen in the real world, and sometimes you need to adapt. But yeah, the point there is that briefcase dev has the -r option as well, so you can reinstall requirements based upon, or into my development environment, based upon what my project definition says should be available. Now, depending upon the network connection and how close attention you were paying, you might have noticed something. When you press the button, the app might have beachballed just for a moment. So you might have seen a little busy indicator pop up. If you didn't, we can do something to make sure it absolutely does. Let's add a sleep to our method. Now, this is completely artificial. You wouldn't do this in real life, but it's a handy way to sort of pretend that we're doing some complicated processing on our JSON response, whatever that happens to be, that takes 5 seconds to complete. Okay, so at the top of your file, add another input. Just import the standard Python time package. And then under the payload processing, time.sleep5. Literally sleep for 5 seconds. Okay? And then show the dialog. So when you push the button, it's going to hit the API, sleep for 5 seconds, and then display the dialog. But when it does that, you'll notice something. The app will freeze up. You'll get either on macOS, you'll get the little spinning beach ball. On Windows, you get the hourglass or the little spinning blue pinwheel, whatever it is. Basically, your operating system is going to tell you this application has locked up. Okay? Take a look at that, try it out, see what happens, or just see that for yourself. So it turns out that the behavior on Windows 11 is slightly different to Windows 10, and I haven't tested on Windows 11 for a while. The app locks up. What you're noticing is that the application, when it gets into that time.sleep, it stops being an application. You can't actually move anything. You can't resize it. You can't respond to it. And on Mac, you get the little pinwheel. You get the little the beach ball icon. Why did that happen? Well, here's a little bit inside baseball. At some level, every GUI framework is essentially the same. While the app hasn't quit, process events redraw. An event is something like clicking a button, a user interaction with the app in some way, a button press, a key press, a resize of a window, whatever it happens to be. Handling that event means calling whatever function you've requested to be invoked when the button has been pressed. So you push the button, that's an event. The GUI toolkit knows to call your say hello method, your I've pressed the button method, and it processes that event. The important thing is that while an app is processing events, it's not redrawing, and when it's not redrawing, or so when it's redrawing, it's not processing events. So if you have an event handler that takes a while to return, either because it's literally sleeping or because it's computing pi to 1,000,000 decimal places or whatever it needs to do, while it's computing that stuff, the application can't redraw. And that manifests as this application has locked up in one way or another. This is a problem. Now, so the way that that displays is beach balls, pinwheels, or just straight up just not responding in the case of Windows 11 apparently. Anything that is computationally intensive includes a lot of loops, reads hardware in some way that could block, like reading a large file, hitting a network API that is slow, anything like that. You can't put that into an event handler because if it takes the time to respond, your app is not going to redraw. Your app will lock up while that processing is happening. Okay, but apps need to do computationally intensive things. Sometimes you really do need pi to 1,000,000 decimal places or read the large file or hit the slow API or whatever else needs to go on. An even simpler case, sometimes you want to have something that's just running in the background. You know, every 5 seconds, do something and update the GUI. But if you can't call sleep in an event handler, how do you do that kind of polling? Well, in most GUI frameworks, the solution is to use threads. You put anything that is computationally intensive or is otherwise blocking into a separate thread and handle it there. An event handler can be used to start the thread, but you then don't block on the thread's completion. You sort of throw the work to the thread does it over there, and the main event loop can kind of just keep ticking and redrawing and doing whatever it needs to do. You can do this in Toga. Python has threading in the standard library. You can just use standard Python threads. Knock yourself out. But anyone who's actually done threading knows threads can be a bit of a headache. There are all sorts of headaches around synchronization and deadlock, but threads in GUIs have an additional complication. Many GUI frameworks will only allow you to make GUI modifications on the GUI thread. So if you're doing some work in a subthread and you want to update the GUI as a result of the calculation of pi that you're doing over here, you can't just update the GUI from over here in this thread. You need to pass a message back to the main thread, and the main thread has to do the GUI update. This is all possible. It is all doable. It is obviously way more complicated than what we'd like to be doing. So the good news is that Toga has another approach. As I said earlier, Toga is a Python-first GUI framework, and Python has first-class support for asynchronous programming. So, as a result, any Toga event handler can be an asynchronous coroutine. How do we make our event handler that needs to do this 5-second sleep asynchronous? Well, we make 5 changes. Instead of it just being a def say hello, we say async def say hello. That declares this is an asynchronous coroutine handler. When we create the client, we say async with httpx.async client as client. That both says, okay, this is an asynchronous handler or an asynchronous context manager, and we're going to create an asynchronous client when we're doing that. When we call the response, we don't just say client.get, we say await client.get. Okay? And when we get down to the sleeping, we don't use time.sleep, we await asyncio.sleep. Functionally, it does exactly the same thing, but it changes the way the event handler is invoked. In particular, the 2 times that we're calling await are requests to say, I'm about to do something that I know is going to take a while. While I'm waiting for it to finish, you can go and do something else. Okay? So await client.get, I am going to start a HTTP request. It might take a little while for this to get back. Give control back to the event loop. Event loop you can keep redrawing. And when the response is ready, come back to me. And then it resumes where it left off. Similarly with the asyncio.sleep. We get to that line, we say await asyncio.sleep. I'm fine for 5 seconds. Go away, redraw yourself, keep running the main event loop for 5 seconds. When that 5-second timer is back, come back and resume where we left off. Okay? So, by doing that, by making this handler asynchronous, we've now given the GUI the opportunity in the background to refresh itself by explicitly calling out the places where this is something busy is going to go on here. Something is going to go on in the background. Okay, so try making those modifications. Key ones here, we need the import async IO, async def, async with, async client, await client, and await async IO.sleep. And you should now notice that in the case of Windows, you can resize the window while it's there, and in the case of macOS, you won't get the little spinning pinwheel while it's doing its sleep. All right, so flags down, pop them back up. All right, so we've got some asynchronous handlers happening. All right, so we've now got an app that remains responsive even when it's doing some busy work, okay? Connecting some dots here that might not necessarily be obvious. The use case for this kind of handler, or if you're doing something like a background polling method, every 5 seconds, hit this API, update the GUI. When it's implemented as an asynchronous handler, it's essentially a while true loop that has an await async IO.sleep 5. You can essentially just have that loop ticking away in the background. It will say, okay, I'm just going to loop continuously, asynchronously, sleep for 5 seconds, then wake up every 5 seconds, do some processing, then go back to sleep again. Oh, yep. This is the reason we didn't use requests. Yeah, requests doesn't have asynchronous support based in. There is an extension package that I think can work, but like there's some architectural stuff that's an issue, so yeah. All right, so we have been using HTTPX, which is a pure Python package we have installed off of PyPI. All right. How do we know that it's pure Python? Well, if you look at the downloads page on PyPI for HTTPX, it has a bunch of wheels to download, and it has a wheel to download, and that wheel is labeled as a Py3 none any wheel. Okay, that is telling you there is nothing platform specific about this whatsoever. It is a Python 3 wheel with no platform specific details whatsoever, purely Python code. Essentially, any package that is pure Python will just work in a briefcase app. Very small asterisk next to that. If it is doing something that is system dependent, so like, something, if you've managed somehow to find a pure Python Bluetooth support module or something, I don't know how you'd build that one, but if it does exist, if there is platform specific code in there, so if the apps code does say if sys.platform equals, you might need to submit a patch upstream to go and add the extra branches for iOS and Android. But if it's just doing, math or something like that, math is not platform specific, it will just run as long as it's a pure Python package. Also, though, note you do need to check the dependencies as well. HTTPX is pure Python, but are all of HTTPX's dependencies pure Python? There are a lot of packages that advertise themselves as pure Python, but they depend on something that is platform specific, and you need all of the dependencies, the full dependency chain needs to be pure Python. If the package you need to install, or any of its dependencies, have binary modules, that's more complicated. A binary wheel is anything that has a platform-specific tag. So, for example, CP310 macOS X 11 ARM 11.wheel. Okay, so if you look at the wheels that are available, and it has an identifier that says that it has to run in CPython 3.10, and it's macOS version 11, and it's an ARM64 wheel, there are usually 15, 20 of these wheels, not just the one Py3 wheel, and there's ones for Linux, and there are ones for Windows, and there are ones for every version of Python. Depending upon which package you're looking at, there can be some variations. But if it's not a Py3 none any wheel, it's probably a binary wheel. And in those cases, they have binary components, which means they need to be compiled. These days, most packages publish binary wheels for macOS, Windows, and Linux. So on desktop, binary wheels just work. You look at NumPy. NumPy has binary wheels. You can just install NumPy and it will just run happily, not a problem. On mobile, binary wheels will just work if a wheel exists. PyPI at present doesn't currently allow you to upload binary wheels for iOS and Android. In fact, at the moment, BeeWare is the only group that is building binary wheels for iOS and Android. And we maintain private PyPI clones where we store all those wheels. We do not have every wheel for every package that is in PyPI. There are quite a few of them, and we don't have an infinite amount of time. So, if you want a package that is on the supported list, not a problem, you're fine. NumPy is on that list, you can install NumPy into your app. If it isn't, building them's a little bit complicated. Obviously, you need to be able to compile this binary code for iOS, compile this binary code for Android, and that's not simple. It's absolutely possible, and we do it, but it's not simple. And quite often, if there's binary compilation involved, there's almost certainly something that needs to be configured to make this code work for iOS, to include the right libraries when it's being linking, or include the right paths for the header files when it's compiling, and so on. This is something that is in the process of changing. As of Python 3.13, iOS and Android are officially Tier 3 supported platforms in CPython, as a result of work that Malcolm and I have been doing with the CPython core team. The next step in this chain is getting the packaging ecosystem up to speed, making sure that CI build wheel and all of the tooling that needs to, setup tools and things like that, that needs to work to support iOS. We need to work with those teams to make that code work. That's a work in progress. It's not there yet. We'll basically be working on that for at least the rest of this year, I suspect, if not well into next year. In the meantime, NumPy, Pandas, Pillow, a bunch of other popular packages have binary wheels that are available. If you want additional binary wheels, check the briefcase documentation that's sort of got some links off to projects that you can contribute recipes for how to build those packages. Broadly speaking, it should be possible to compile any wheel for iOS and Android. That doesn't mean it's simple. Any binary libraries that the wheel uses also need to be available. So, PIL, the Python image library, uses libjpeg. That means you need to have libjpeg for iOS. You need to have libjpeg for Android. In turn, those packages may have binary dependencies. They need to be compiled for iOS and Android, and so on and so on. And some packages get very, very complicated to compile. SciPy and OpenCV, for example, both require a Fortran compiler to be able to build them. Apple doesn't provide a Fortran compiler for iOS, so, okay, we need to work out how to fix that. You also need to be a little bit wary about wheel size. In the last year or so, we've seen a lot of people get very, very enthusiastic about the prospect of putting LLMs into mobile applications. Great idea, knock yourself out. From a code perspective, it's not that hard. The code behind an LLM is not that complicated. It's literally just math in a lot of cases. The problem is that the compiled components are relatively straightforward, but the data files associated with a trained language model can be multiple gigabytes. And an iOS and Android app needs to be self-contained. Even a macOS or Windows app, it needs to be self-contained. And so all of a sudden you're in a situation where your bundled app is a 4 gigabyte app, 3.999 gigabyte of which is one data file. And on desktop, that's workable, but Android has a 512 megabyte hard limit on the size of binaries that you can upload to the App Store. And iOS App Store apps that are 4 gigabytes aren't very common. So you need to be aware of the limitations of the platforms you're working with, and file size is one of those limitations you need to work with. So, an exercise to try this one out, try adding NumPy to your app. Okay, we have got an app here, we've got it popping up, a dialog box. Try adding to the message that is printed a random number that's been generated by NumPy. Okay, we should be able to say, add NumPy to your requirements, run briefcase dev -r to make sure that it's working in your local, or to add it to your local environment. And in your code, import NumPy as NP, value equals np.random.randint. It will generate a random number between 0 and 100, stick that text into your dialog box somewhere, run it in development mode with -r to make sure it's installed, run it as a desktop app with -r to make sure the dependencies are installed. And those of you who got it in mobile, you can try it out on mobile as well, again with briefcase run iOS -r or Android -r to make sure you're getting the binary versions of NumPy available for your mobile app. Those of you who are running Android, as the download's been finishing in the background, you hopefully will have a running Android application at some point in the background there. So try that one out, see how we go. Yep. All right. So we've added a binary dependency to our app, rerun with -r to make sure those dependencies are installed. Those of you on macOS particularly, with one exception, with a bug we just discovered, will have noticed that it did the install twice. It also outputted some warnings about the files having different content. This is because macOS currently supports two CPU architectures, x86 and ARM. Many projects, including NumPy, only publish single architecture wheels. So Briefcase produces universal apps that will run on both x86 and ARM, and so it needs to install the ARM version of the wheel and the x86 version of the wheel and then merge the two together. If you look closely at the log messages, we'll notice there's a couple of files there that are inconsistent. It warns you about those. Mostly, you need to audit those to make sure that they're actually okay to ignore. In the case of NumPy, they are. Some headers and static libraries, it's arguable whether they should be in the wheel at all. But yeah, so anyway, Briefcase then manages the process of making sure you've got all of both architectures' sets of requirements packaged together in a single universal binary that you can then run on x86 or ARM. At some point in the not too distant future, that problem will go away when Apple stops supporting x86, which is probably a year or two off. Anyway. So far, our application has used a little, oh, sorry, yep. Yep, there is. There's a configuration option you can stick into your macOS section to say universal build equals false, and it will only build for the platform you're currently on. So if you build it on x86, it will be an x86 app. You build it on an ARM, it'll be an ARM app. All right, so far, our app has used a stock grey bee icon. Let's customize our app a little bit, give it some personality. If we modify our pyproject.toml, we can add an icon definition. This is again up in the app section of the block or the project section, either one. Say just before the sources definition is probably a decent place to put it. And then run briefcase update -- update resources. Okay, that will update your app, but it will also update the app resources, which are things like the icons. What you'll see will be very slightly different depending upon your platform. On macOS and Windows is a single file. On Linux, it's 6 files. The list of the actual icons that you need is different on every platform. That's why the icon setting, when you say icon equals icons/hello world, it doesn't include a file extension. It doesn't say .png or .ico or something like that. Briefcase uses the value of the icon setting as a prefix and then appends suffixes to generate either the single file that is needed for a platform or the multiple files that are necessary for the platform. If we just add the setting, icon equals icons hello world, and then run briefcase update resources, you will see a message that says unable to find icons app hello world.icons or whatever the platform or whatever the icon requirements are for your given platform. That is entirely intentional because we actually haven't put the files in place. So if we then download the zip file at that URL location, unpack that zip file into the root of your project, so you should then have an icons folder next to your source folder, next to your build folder and your dist folder, and run briefcase run -- update resources again. You should say it's going to install icons hello world.icons as your application icon. Inside that icons folder, you will see 30-odd different icons. That is the full set of icons you need to define or to customize your application for all of the platforms that Briefcase supports. A lot of them are Android icons because Android has 3 different formats of icons in about 5 different sizes. It is what it is. If you run those steps, you put the icons hello world or icon equals icons hello world in your app config, and then run briefcase run update resources, then you should see your application start up, and what you'll have is the icon that pops up for your application is now a little blue background with a green snake rather than being the little grey bee that we've been seeing up to this point. All right, so try that one out. Yep. So just drop it into the root of your project. So you should end up with like a source, build, dist, and icons. Okay, so that URL, the BeeWare tutorial icons, is a zip file. Just unzip it in that folder.
So in every project, you go to source, we create a folder called build.
No. Okay, in your existing project, you should at this point have a sources folder, or a source, build, dist, and we're adding an icons directory, which will come out of the zip file. The zip file contains the icons directory. In the PyProject.toml, yep. So yeah, just above the sources declaration. It'd be as good a place as any. Yep.
Is it okay to run different briefcase commands at once? For example, one in one building and the other iris.
Yep. You wouldn't want. Sorry. Yeah. You wouldn't. Little blue snake icons everywhere. Yep. All right. So if you run that app on a mobile platform, so if you were to run this on iOS, you'll see that new icon appear on the Launchpad as well. There's another place where that icon will be seen. It's also on the splash screen. So when the app starts, it shows a splash screen just to let you know that it's loading when it starts. And that icon, or the icon, is used for the splash screen as well. However, this particular icon that we're using, it's got a blue background, and so the icon ends up with like this sort of blue square in the middle of the splash screen. That's possibly not something you really like. You'd like to have it, the whole thing be the same color. You can modify that by adding splash background color to PyProject or to your PyProject.toml. That there's just a hex color code that you want the background to be. It's the same color as the background of the icon. The catch is, though, once you change that background color, you actually have to recreate the entire project. Okay. Now, I mentioned earlier that you should basically be treating the PyProject directory as ephemeral. Okay. Anything in the build directory you shouldn't basically be counting on as being there later on. It's generally speaking, you kind of assume that the entire build directory is going to be deleted every time. You can keep it around because it makes subsequent builds a little bit faster, but you definitely shouldn't be committing your build directory to version control or anything like that, or making local modifications. Deleting build and starting from scratch should essentially always be your release strategy. You need to recreate the app anytime you make a change to your PyProject.toml file that doesn't relate to source code or dependencies. So for example, here if you're changing the descriptions or version numbers or colors or permissions, you need to do a recreate step to regenerate your entire app. The reason for that is that making that color change actually requires making modifications to, for example, the Xcode project or the Android configuration files, and the only way we can reliably get that file in there is basically to delete it and regenerate it from template. So that means that it's generating from template. If you ever discover a situation where the content that Briefcase is generating from template isn't right for your situation, and Briefcase doesn't provide a configuration point to let you get in there and insert a customized value, you can define a custom template. Briefcase's templates are all just GitHub repositories that contain cookie cutter templates. You can fork that repository, add a template setting to your project, and Briefcase will use your custom template. We are running a little short on time, so I think from here I'll sort of go through what we're going to look at for the rest of the rest of the tutorial, and download the slides and sort of work through the rest of these at your leisure. This will at least give you an idea of other things you could be doing with Briefcase, other things that can sort of capabilities that Toga and Briefcase have. One of them is device hardware. So far our demo has been fairly vanilla GUI code, but we're running on a phone. So we'll do something sort of cool with that fact and actually use some device hardware, specifically the camera. We do need to add some more code to our app here. There is a link there off to some code. At that URL is a gist with 2 code snippets that come in 2 parts. First, we need to add a new button to trigger the camera. We need to add a placeholder image view where we can put the photo that the camera has taken. The code needs to create those widgets and put them into your overall application layout during startup. You should be able to sort of work out how that fits into the overall picture, but it's basically just adding it to the right containers, instantiating the widgets, adding it to the right boxes so that it lays out in the order you want. Second, you need to add a handler for the button that actually takes that photo. That's a method that's attached to the app class, same as the say hello handler. So you've got this take photo handler. The hardware APIs are all asynchronous. So if you ask the hardware to do something and then you await the response, you ask for permission to use the camera and then you await the response when you have that permission. You will ask to take a photo, you wait for it to receive that photo. And in the case of an error, you ask to display a dialog and then await the user to say, yes, it's okay for me to continue. All right? The code asks for permissions, but you can't just ask. You actually need to declare as part of your app configuration that you're going to ask. You can do that in Briefcase by adding a permission.camera declaration to your PyProject.toml. The string that you provide, so in this case, permission.camera equals app will take mugshots. That string is, depending upon the platform, might be displayed to the user to explain why you need to access the camera. On iOS in particular, that is a hard requirement, and your app will get rejected from the App Store if your explanation of why you need to add the camera or need to use the camera isn't good enough by whatever Apple judges to be good enough on the Tuesday that you decide to submit your app. So yeah, you need to give a good explanation of why you need to access the camera. It can't just be because I want to take a photo. Briefcase has cross-platform permission to support the camera, the microphone, geolocation, and the photo library, but there are also mechanisms to inject any other platform-specific permissions that you might need to use. So, for example, on Android, if you want to use Bluetooth, you need to explicitly declare that you want to use Bluetooth LE or act as a Bluetooth server. You can add an Android-specific declaration for those as well. Again, because we're changing app permissions, you need to recreate the app. Permissions are declared in files that are generated by the application template, so you need to regenerate your application template. So that's a full Briefcase create, Briefcase run. Now, caveats as far as this demo is concerned, the code will work on iOS, but it won't work on the iOS simulator. For some god unknown reason, the iOS simulator doesn't have a working camera. However, it will work on macOS, so you can actually run the camera demonstrator or use the camera API on macOS. If you decide to run on an actual physical iPhone device, the camera works fine. It's just the simulator, for some reason, doesn't have a camera. On Android, the emulator does have a camera. It's this little Minecraft face that kind of bobs around in the screen pretending to be a camera, and you get a photo. Yeah, you'll know it when you see it. It looks odd, but it's at least lets you take a photo, which is a step ahead of our iOS, I guess. Linux and Windows users, unfortunately, you currently miss out on desktop camera support. You should get an error message if you try to access the camera or access permissions to take a photo. Yeah, so if you wanted to test this out, you actually do have to do this on mobile at present. We would love to fix this. I just don't know enough about iOS and Android and... Try that again. I don't know enough about Linux and Windows camera APIs to implement it. So if that is an area where you have any expertise, we'd love the contribution. Okay, so far we've also been writing code using Briefcase Dev to check that code works as we expect, and that's fine for a toy app like this, but if you're building an app for real, you kind of want to have tests for that code as well. Your app will have business logic and your app will have display logic, and you really want those tests to be run in an environment that's as close to production as possible. So if you're developing a mobile app, you kind of want to run those tests on a phone environment so that you can verify things are actually going to work as you expect. Classic example here is validating that NumPy is actually working on your iPhone app if for some reason you need NumPy. So Briefcase also supports running in test mode. Both development mode and packaged apps can be run in test mode. So you can run a test suite on a device simulator, and the stub app that we've generated already contains a test suite. If you look in your generated project, there is a tests folder that contains a test app.py with a vital test of mathematical logic. If you say Briefcase dev --test -r, it will run your app in test mode, making sure that it has installed all the requirements for your test app to run. Because your test app requires PyTest, it needs to install PyTest to make sure that you can actually run the test suite. The first time you run in dev mode, you need that -r. Subsequent times you run it, your dependencies are there, your PyTest dependencies or your testing dependencies are there. That's why also there is a difference between requires and test requires. And test requires lists the PyTest requirement. So yeah, if you run that, Briefcase dev --test, unless the laws of math have changed, the test suite should pass. It tells you it ran one test, everything's fine. You can then use that capability to do some test-driven development. So if you want to get a new requirement from upper management, you want to, whenever the user's name is Brutus, you want to provide a customized greeting, you could go and write a bunch of tests to validate that the greeting method behaves the way you expect, validate that the tests are returning the right values, run briefcase dev -- test, and then also you could run briefcase run -- test to validate that it works correctly in the runtime environment. So example there, running that test mode on device as well, briefcase run -- test, briefcase run iOS -- test, briefcase run Android -- test, running test mode on all those devices. Okay, so wrapping up, that's the end of the formal material that I've got today. Before we sign off, a few more high-level details about BeeWare, Briefcase, Toga, things that we haven't had a chance to look at today. Firstly, Briefcase Open. Open is a shortcut for opening your app's project folder in your file manager. For the examples we've done today, it's mostly a convenience for spelunking around wherever we've been debugging. However, on iOS, it will open Xcode for your project. Okay, so if you've got an Xcode project and you say briefcase open iOS, it will open the Xcode project for your iOS version of your app. That is needed if you want to run on a physical device or to publish the app to the App Store, because the publication process actually requires you to use Xcode and log into Xcode to bundle things. There is documentation, Briefcase's documentation describes how to go through that runtime process. Part of the issue is that you actually need to physically sign an application with a developer certificate. That means you've got to have a developer account with Apple. That's a $99 a year subscription. I think there are educational and other discounts available, but you've got to have that developer certificate. Your phone has to be configured with it. Then you've got to go into the Xcode project and select that this is the developer who's going to run this app, and then you can physically have it on your phone. I've got a bunch of apps on my phone that I've been developing that I haven't pushed to the App Store, but are running happily on my phone. You can also use Briefcase Open for macOS Xcode projects. Remember, macOS has two formats. There's the app format and the Xcode format. Or Windows Visual Studio projects. You can open Visual Studio on a Windows application or on the Windows template for that as well. It is also really useful for Docker-based builds. I mentioned earlier that Briefcase can use Docker to target different Linux distributions. Briefcase open -- target will open a shell in the Docker container that's being used to build your app, which if you're spelunking to try and work out, what has Ubuntu changed this week in its version dependencies of, GTK or whatever, it's sometimes handy to actually be in the Docker container that you're trying to build to work out what commands will actually work, what dependencies do we need to install, then go back to your main project and make those modifications permanent. Another command that we didn't use is upgrade. That's used to upgrade the tools that Briefcase manages. Several points during today, Briefcase has downloaded tools that we needed to run, Java, the Android SDK, Wix and ResEdit for Windows. There are some others. Sometimes those tools need to be updated. It doesn't happen often, but when you do, Briefcase Update will just do all those downloads for you and make sure they're all up to date. In terms of building BeeWare apps themselves, one big conceptual jump that people often need to get over, BeeWare apps are just normal Python code running as Python code. How do I do X in BeeWare? Well, how do you do it in Python? Do that. There are a couple of exceptions, but they're mostly an issue on mobile platforms. The first one is fork and spawn. Fork and spawn are problematic for two reasons. Mobile devices don't do parallel multitasking, so you can't run multiple executables at the same time. The place you're most likely to have come across fork and spawn is the multiprocessing library. So if you're used to doing multiprocessing to spawn multiple versions of your app running in multiple processes, you can't do that on mobile because you can't spawn a second process. The other one is TK. TK is a problem because it is a GUI toolkit. Python ships with a GUI toolkit built in, TK Inter. It has not been ported to iOS or Android, and so TK apps will not run on iOS or Android. It is also a real pain to distribute on pretty much every platform except Linux. Getting the Windows embedded build for CPython doesn't ship TK Inter because it's almost impossible to distribute in a standalone way. Other than that, though, the good news is that basically anything you can do with Python, you can do inside a BeeWare app. You want to use threads? Python has threads. Use them. Same goes for anything else in the standard library. There are also some other benefits. Remember we looked at our About menus and Help menus. We saw that it was using metadata from our pyproject.toml. That's because all of your app's metadata is included as PEP566 metadata, which you can read at runtime. Python 3.8 added input lib.metadata, and that metadata can all be read at runtime dynamically. So you can get the author's name, you can get the version of the app, you can get all these details at runtime by interrogating that application metadata. Here was this, oh yeah, so the keys aren't exactly the same as they are in the briefcases specification. The app name, for example, is named. That's for PEP compatibility. PEP566 uses slightly different keywords. That all sort of details are all the platform limitations. What about when you hit the limits of what BeeWare can do? Well, BeeWare is a collection of layered tools, so using the lower layers of your operating system is always an option. So say you're on iOS and you want to be able to use the accelerometer. Toga doesn't currently provide a wrapper for the accelerometer. You don't need to wait for us. You can just call the accelerometer APIs natively on your platform. If you can find a native Objective-C API that iOS provides, you can just invoke it. On macOS and iOS, there's a library called Rubicon Objective-C, which is a dependency of Toga. We use Rubicon Objective-C to build Toga to call the native APIs for creating a button, for creating a window, for creating a text label. You can also use those libraries to call any other API that's in the Objective-C code space. Similarly, on GTK, we use GObject. You can use that to access any other GTK API. On Windows, we use Python.NET, any CLR assembly you can install and you can use. On Android, ChakaPy will let you access any Android library. These are all platform specific, and there are some tweaks and oddities about how do you wrap Objective-C in Python and how do you access Java from ChakaPy. But they're all reasonably well documented. You can sort of access those libraries, and once you've sort of wrapped the class that you want to access, the APIs that it's exposing, it's mostly a sort of transliteration between the name of the method that the Android documentation says you should call and just calling that method in Python. You could, if you wanted, even go all out and just build an entire iOS or Android app using Rubicon and ChakaPy. Never use Toga at all. Like, just literally go and get the Hello World tutorial for Android development and implement it in ChakaPy. Do the same for the Hello World tutorial for iOS development and write it using Rubicon. It would be tedious, and I don't know why you'd do that instead of just following the tutorial the way it's been written. But it's make the point. It's possible. You could call everything that you're doing natively, or all the native APIs can be invoked completely natively. And that's basically the tutorial. We have covered a lot today. We obviously didn't get through the whole thing, but the slide deck does contain all the content you need to complete those last couple of steps. If you want to know more, Briefcases documentation describes a whole lot of configuration flags we haven't gone into today. There are all sorts of depths and weird stuff that you can configure in the way your exact project is running. Toga's documentation also, there's a bunch of widgets that we haven't looked at. There's a map widget, there's all sorts of tab controls and table controls and detailed list controls that you can use. Toga's repository contains an examples directory that's got like 20, 30 different applications just showing off things you can do with Toga. They are all reasonable examples of ways to show off things you can do. And a lot of the code that we've got here is actually from the BeeWare tutorial itself. So if you go through the BeeWare tutorial, you'll see some very, very familiar things of what we've gone here, but it will step you through a lot of the processes we've been doing. If you like what you've seen here, you'd like to support the work on BeeWare and the Briefcase and the BeeWare project, you can join the project as a financial member. You can also back me and the project on GitHub sponsors. That income is currently enough to cover stickers. Those of you who didn't see before, we've got some stickers here if you want to grab them. And things of that nature, hosting, the things that cost because you've got a project on the internet. Like I said earlier, Malcolm and I are paid by Anaconda to work on BeeWare, but Anaconda doesn't pay for the project. They don't pay for the stickers. That comes out of the income that comes from contributors like you. Or if work in kind is more your thing, we are always looking for new contributors. We have a long list of features we'd like to add, and we have challenge coins. We've actually got genuine BeeWare challenge coins if you'd like to come along and contribute. We will be here for Malcolm and I think you as well, Russell, are here for the first 3 days of the sprint. Is that right? Yep. So if you're looking for something to work on for the sprints next week, come and say hi. We'll have a bunch of banners you see, come find the banners, we can find something for you. And if you think, oh, but I don't have enough experience to contribute, we have found someone who learnt to use Git 2 hours earlier who has commits in the BeeWare codebase. When we say we can get anybody into the codebase, we will find something for you to work on. As far as the community as a whole, we have a Discord, we have discussion forums, we've got ticket trackers, details on the website, beeware.org. Thank you all very much. Oh, sorry, and the one thing I did leave off, we've actually got a booth in the community section as well. So if you do want to come and continue to pester me with questions or whatever you've got, or ideas or things you want to play out, we'll be in the community section for the first 2 days, or from tonight and then Friday and Saturday. So.